So, what if I told you that the secret to teaching the complex physics of sound is sitting right inside your recycling bin? Seriously, let's dive into this incredible idea where we can literally transform empty boxes and plastic bottles into a powerful, hands-on learning experience.
Oh, it absolutely can. Today, we're going to break down a project called the Trash Can Band. It's this super engaging and totally scalable STEM project where students get to build their own musical instruments from stuff they were just going to throw out. And in the process, they start to intuitively grasp the fundamentals of sound.
You know, the method behind this magic is something called project-based learning. So instead of just sitting there memorizing facts from a lecture, students are actively working to solve a real-world challenge. This is how they develop those crucial 21st century skills. We're talking about creativity, teamwork, and real problem solving.
And what's so brilliant about this whole idea is how it scales. It's not a one-and-done thing. We're going to start with a super fun, hands-on project that's perfect for kindergartners, and then we're going to level it up all the way through high school, bringing in coding, artificial intelligence, and even some serious engineering. Let's see how it all connects.
Okay, first up, our youngest learners. We're talking kindergarten through 3rd grade. The goal here is simple but really exciting. We're starting a band, and the only rule is you have to use things you were going to throw away.
So they get rubber bands, cardboard boxes, plastic bottles filled with dry beans, you name it. And as they start stretching those bands over boxes or shaking beans in bottles, they're not just playing, they are actively discovering physics. They learn firsthand how different materials and tensions can create loud, soft, high, or low noises. And then, the best part, they can compose and even perform a little concert.
And here's a really simple but powerful tip for teachers. Before a student strums their new box guitar, just ask them to predict what kind of sound it will make. It's a tiny step, but it encourages critical thinking and makes their discovery moment even more memorable. It gets them thinking like a scientist.
So how do we level this up for the older kids? Well, this is where we take a huge digital leap. We start bringing in technology to build on that physical foundation they've already explored.
For grades 4 through 6, we introduce block coding. Students can move from their physical instruments to programming their very own interactive digital keyboards. They learn how to code specific sound waves to play when different keys are pressed. It's such a fantastic and creative way to introduce the logic of computational thinking without it feeling like a boring math problem.
And maybe the best part is how accessible this is. A tool like Scratch is completely free and it's all web-based. That means any classroom can get started in minutes without needing to download special software or create a bunch of accounts. It's just ready to go.
All right, moving into middle school, things get even cooler. We introduce artificial intelligence as a creative partner. Students can now use generative AI tools to brainstorm original lyrics for their songs, or even compose a digital backing track to go along with the physical instruments they've built. This is where the physical and digital worlds really start to blend.
But this is so important. The approach here is key. We are not letting the AI do the work for them. The goal is to use it as a powerful brainstorming buddy, teaching students how to collaborate with technology, not just outsource their creativity to it.
So for example, instead of just asking the AI to write lyrics, you have the students prompted to act as a co-writer. The AI can then ask them questions about their song's theme or what mood they're going for. This guides their thinking and, crucially, keeps them in the creative driver's seat.
This chart really lays out the whole journey beautifully. You can see how we start with the tangible, physical world, the physics of sound. Then we build into the logic of computational thinking. From there, we learn creative collaboration with AI. And finally, we graduate to some pretty serious data analysis. It's this seamless progression that builds essential skills year after year.
And that brings us to the final stage, the absolute pinnacle of the project for our high school students. This is where it evolves into a full-on engineering showcase.
At this level, students are diving deep into the physics of sound waves. Their challenge? To engineer their own acoustic amplifiers from scratch. They're not just creating sound anymore. Now they're measuring it, analyzing frequencies and amplitudes, and presenting their data and findings to the class like actual engineers.
And just like with Scratch for the younger kids, you don't need a fancy, expensive lab for this. There are fantastic free tools out there. Audio analysis software like Audacity lets students actually visualize and measure the acoustic data from their creations, which brings this really professional, scientific layer to the whole project.
So, when you look at all 4 of these stages together, from a simple shoebox guitar all the way to a data-driven amplifier, you start to see the real lesson of the Trash Can Band. You see, the process itself is the point. It's not just about the final instrument. Whether they're making a simple shaker or coding a complex synthesizer, students are building something from nothing. And through that process, they learn one of the most valuable lessons of all, that it's okay to fail because you can always try again and you can ultimately succeed.
And the outcome of all this? Well, they walk away with a whole suite of modern skills that go way beyond the physics of sound. They learn real collaboration, communication, and problem solving. And for the older students, they gain a practical AI literacy that is going to be absolutely essential for whatever they do in the future.
And all this really brings us to one final question. If a recycling bin can become a physics lesson and a recording studio, what other everyday objects are just waiting to be transformed? What else could your students build to learn?